All right. Well, good morning, folks. How's it going? Any issues? Maybe something you want me to go back over a little bit? Excuse me. Yeah, I was wondering, I think Jeremiah, it was you yesterday that I didn't notice was you were waiting. I was just wondering if you're in the waiting room, can you, before I admit you, can you see me before I let you in? Anybody know the answer to that? No, you can't. All right, you see nothing. Okay, yeah, that's too bad. Well, maybe that's somehow appropriate, but yeah, just wondered. All right, well, we're going on today. Hi, Maria, did you want to say something? Yeah.
However, when we put you on no screen, I could still hear you.
Oh, okay. Yeah, even though.
Even though, like, I turned my screen off.
Right, right. Do you see me when you turn your screen off?
I don't see you. I could just hear what you're saying.
Huh. Okay.
Well, because I'm away from my screen, but if I walk away, I can still hear what's happening.
Yes. Okay. Good. Just kind
And
of
I can still see you.
getting used to this platform, right?
Thanks, sorry.
Well,
Stephen.
yes.
Yeah, yesterday I got knocked out of the class, and I was actually curious. I went back and I watched the video, but us being here is this like part of our grade as attendance?
No, it's not. No, it's not.
Okay.
That's kind of nice flexibility for you, and the fact that I'm able to record these sessions. Yeah, it's good for everybody. Yeah, you can watch them later, and I've even got students I think who are working all day and they're going home and watching the videos or something like that.
Right. So then, like, in saying that, we wouldn't have it's not like mandatory to see every Zoom meeting.
No.
Okay, that's
even when I was in the classroom, after the sort of the first week requirement where I have to take attendance to make sure you're in the class, I don't count attendance. I make, it's up to you to be responsible and do what you need to do. Okay. So.
Wait, I have a question.
Yes. Hi, Christine.
So I read on the syllabus on a different class that the Zoom meetings count for attendance.
Well, I'll double check the class meeting. I'll double check that. And
Okay.
I haven't done that in the past. I wonder if I started out thinking I would do that. The discussions, that is, in the forum, posting something weekly in the discussion forums, that's going to be part of the grade. Okay.
Okay.
All right. So, but thanks for pointing that out. I'll go back and double check. It wasn't it's not what I usually do. And so at this point, I don't plan to do that. Count attendance. All right. Okay. Well, anyway, we're into 110, section 1.10 today. Unit conversions, systems of measurement, whatever the title of that section. What is it? Oh, yeah, systems of measurement. Basically, converting between units within the English system and the metric system, and then between the two systems. Some of them won't seem complicated, and of course others get more complicated. And our whole process is based on a conversion factor, some sort of equivalence. This unit equals this many of that unit, right? And so, for instance, hopefully if you're looking in my open map at this section's homework, near the top of that assignment should be a link that links you to a table of conversions. And you can either download it to your computer or print it out to have it handy, but those will be the conversions that you'll need to answer those questions. Come test time, the question or two in this topic that you might see will usually have the conversions right there in that question. These are what you'll need to use to answer this question. So you don't really need the whole worksheet there with you usually. But okay, so for instance, right, a conversion factor. Some ones we're probably real familiar with. you know, 1 foot equals 12 inches. All right, okay, so there's this conversion relationship, this equivalence here between those two sets of units. And so a question might ask you to convert, well, even put in a decimal or something, you're going to use your calculator, right? 3.5 feet to inches. Now, this one, you might say, well, that's not too hard. I'm just going to multiply 3.5 times 12. Yes, we're going to come up with a process that works for even the more complicated ones, all right? So the whole thing about using this as a conversion factor is you kind of have to build a fraction out of that relationship. Kind of go through long answer here. If I was to divide both sides by this 12 inches, settle down, all right? I get a 1 over here. I'm going to move down here. So this is one relationship. 1 foot equals 1. That's sort of the mathematician saying, I can multiply anything times this, and it doesn't change the value because it equals 1. Right? Canceled out here. If I go backwards the other way around, if I multiply both sides by the 1 foot, I get the fraction upside down. Right? If I multiply both sides by 1 foot, then I get the inches on top and the foot on the bottom. Okay. All right, so how does that help us? Well, you see how this conversion works then. You have to figure out which version of that relationship you're going to use to change from the units you start with to the units you want to end up with. I always take the number in the problem that you start with, and I'm going to multiply by one of those two fractions. So I make this one always look like a fraction by just putting it over a 1. So whatever number you get to start, sometimes it has 2 numbers in it, and so it is a fraction, but most of the time it doesn't, okay? So I start with that one, and I'm going to multiply it by one of those 2 versions I just mentioned, so that when I am done, I have inches left and no more feet. So I almost kind of set up my problem like this every time. And so now I want to figure out which version of that fraction that I made there do I want to plug in here. Well, you always want to use the one that starts with the starting units on the opposite side of the fraction. Then it's like a common factor. The units will actually cancel out like you were reducing a fraction to lowest terms. So without even worrying about the numbers, I said, oh, I want the feet down here and the inches up here. Then no matter what numbers I have to put in for that relationship, the feet cancel out, kind of like I mentioned, a common factor. And I'm going to be left with the inches that I want. Well, okay, what are the numbers in this problem? 1 foot and 12 inches. So yes, in this one, this relationship, it does turn out that I end up multiplying 3.5 times 12. And that's going to tell me how many inches. 36 and 6, you can do that in your calculator, but I think it's 42. 42 inches, so 3.5 feet, 3.5 feet is equal to 42 inches. So this use of the conversion factor, that relationship that you've turned into a fraction to multiply by, is this consistent process that you want to see if you can get a handle on that so you can use it regularly. All right. Now, what if I was going the other way around? I'm going to erase that one, okay? What if I had, say, 66 inches and I want to change it to feet? All right. So I'm using that same relationship, feet to inches. This time I'm going the other direction. Here's my 66 inches. Again, I'm going to make a fraction out of that so I can multiply by a fraction. Just, making it look like it's going to make sense. And I want to end up in feet. So now I'm going to take that relationship, 12 inches per foot, and put it in this fraction So that now inches is on the opposite side and feet is on top. Now the inches will go away, top and bottom, right? Cancel them out, and feet will be left. So 1 foot is 12 inches. Put the right numbers in there, right? If I think about my units first, that helps me to get that in the correct orientation. And of course, be careful you get the numbers in correctly then. So now in this case, I'm actually dividing 66 by 12. And you can do that in your calculator. Any numbers on top, it's like multiply those together. Anything on the bottom, you divide by that number. And sometimes there's more than one in a row. Divide by that. Divide by the next one. Now I made up some nice numbers. I can do it in my head without my calculator right here. 12 goes into 65 times, and then there's 6 left. So that's another half. So this should be 5.5 feet. You can double check me in your calculator if you'd like. But 66 divided by 12, I believe, is 5.5. So here I use that same relationship, but in the opposite orientation, because I was canceling inches this time. All right. All right. Just going to do a bunch of these different versions. So there's one with lengths. All right. We'll do more complicated things in a minute. Tons to pounds. It's like, oh, maybe you know that number, but gee, it's on my weight sheet someplace. And I have a conversion that says 1 ton equals 2,000 pounds. So I'm going to use that relationship to build my conversion factor. Make that look like a T a little better, all right? So here's my starting. And I'm going to end up in pounds. Just trying to set it up the same way. I'm going to build that fraction out of that relationship. Well, I want to cancel out the tons and leave in or introduce pounds. That tells me where to put the numbers. Oh, 1 ton, 2,000 pounds. So yes, now I am multiplying 4.3 times 2,000. 2 times 4.3, that'd be 8.6. How many zeros do I want in there? I did that in my head. 8,000, yeah, 4 times 2,000, it'd be 8,000. There, I think that I got the right number without using my calculator. You can use your calculator, all right? So just a similar setup, to, regardless of what kind of units we're talking about here. All right, how about, what if I had, I'm going to make something really messy, and I'm going to grab my calculator in a second. What if this is MI from miles, all right? And I'm going to convert that to inches. I'm going to grab my calculator here. Well, if I'm, make sure it's going to work. If I'm going from miles to inches, I might look at my conversion table here and say, oh, there isn't one that goes directly from miles to inches. Well, but I do have one that goes from miles to feet. And we've already used one that goes from feet to inches. So here's where they get a little more complicated. You might need to use a chain or string of conversions. So I'm going to need to multiply by 2 of those conversion factors in a row. Now you can kind of do it in one step, but see if you can figure out if this can make sense to do it in one step. I think it's easier. Here's the 2.5 I'm starting with, the miles. And now I'm going to need 1 factor that changes from the miles to the feet. And then I'm going to need another one that changes it from feet to inches. So I'm just putting these all in a row over here, and then on equals will be my answer on the other side. So I've got to set up the units correctly for two different conversions. So to go from miles to feet, right, I want to put miles on the opposite side, and that puts the feet on the top. When I do that, that's going to allow the miles to cancel out, and I'll have some sort of number in terms of feet right now. At the next factor, notice these are no equal signs yet. I'm just multiply, multiply, multiply. I'm going to put feet on the opposite side of where I put it there, and inches on top. And that's going to allow the feet to cancel, and I'll be just left with inches. It's going to be some really big number of inches, right? So 1 mile, whoops, 1 mile is 5,280 feet. Almost put a number on there backwards. All right, and so that's set up. Now 1 foot is 12 inches. Well, that's kind of nice on the denominators. It's still 111. It's not always going to be like that. Sometimes you got numbers on top and some on the bottom. But now I can multiply all those together. Here's definitely where I'm going to get out my calculator and clear all and say, what did I say? 2.5 times 5,280 times 12 and more room. 158,400 inches in 2.5 miles. Isn't that something you really want to know? But this is an example where I needed to use two different conversions to get where I was going, where I wanted to end up. So I put them in a chain. Now, I could have done it, like I said, in 2 steps. I could have just done this first part and come up with an answer in feet, and then kind of started over and set it up feet to inches. But I would have just been doing the same 2 things, just in separate steps. But if you're more comfortable with that, that's okay. Show your work. So that's okay. I'm gonna keep moving. All right. And let's do one that gets even a little more complicated. All right. Convert 50 miles per hour. That fraction bar is just the word per, okay? That's, get okay with that. Can change miles per hour to feet per second. Again, that fraction bar is like the word per. So this is what we call a rate. When you're comparing 2 different kinds of units, miles per hour, cost per ounce, weight per gallon, when you're comparing 2 different kinds of units, that's referred to as a rate. How much does this value change for a change in this other value? So this is really 50 miles for every 1 hour. That's how fast you're traveling. And I want to figure out, well, how many feet per second am I traveling? So I actually have 2 kinds, excuse me, of conversions to do here. I have to change my miles to feet, and I have to change my hours to seconds. So there's 2 types of units that I'm converting. I can still just kind of do that all in this chain, just keep track of where I am. So I'm going to start with the 50 miles per, I'll put the 1 in just like a placeholder for 1 hour. Now, what do I know? I'm changing miles to feet, but we just saw that one a minute ago. 1 mile, 5,280 feet. So I'm just going to use that conversion factor, that relationship, to change my miles to feet. So I'm going to put that one in here to change miles to feet. So miles opposite where they started, and feet opposite up there. Feet up there. That's going to get me a number that cancels out the miles, and now it's a number of feet per hour still. All right. Well, now I need to, I'll put the numbers in. 1 mile, 5,280. Now I need to change the hours to seconds. Usually we don't think of how many seconds there are an hour. In an hour, if you know that number, fine, you can do it one step, but I know 1 hour is 60 minutes and 1 minute is 60 seconds. So there's 2 steps I'm going to use to change hours all the way to seconds. So I have those 2 relationships to plug in now in 2 different fractions, and eventually I'm going to get feet per second at the end. So now this is just a bunch of factors in a row. You can do the minutes first, right? Commutative, we can change places. But hours and minutes. So hours starts on the bottom this time. So opposite would put hours on top and minutes on the bottom. Right now we already gotten rid of miles. This is going to get rid of hours here. And now I'm going to go from minutes to seconds. Minutes started on the bottom. So to cancel it, I need it on top, and the second goes on the bottom. Oh, look, that's where I want it to be at the end. All right. So that's going to get rid of the minutes. 1 hour is 60 minutes. 1 minute is 60 seconds. Now you can do the calculation a couple different ways. I could do 50 times 5,280 and get a big number on top. And I could do 60 times 60 and get a big number on the bottom, and then do the division. Or, like I mentioned a second ago, any number on top, like multiply, 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 and any number on the bottom is divide, 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 divide. So I'm going to write this out like a string. I can type right into my calculator. 50 times 5,280. Then those are ones, so divided by 60 and divided by 60 again. Multiply, multiply, divide, divide. If I type that right into my calculator, I'll get there in 1 step. Yep. Otherwise, hopefully that makes sense. I build a fraction with 2 big numbers, and I divide the top number by the bottom number. But here goes. 50 times 5,280. Divided by 60, divided by 60. Don't even have to hit equal in between until the very end. And I got 73.33333. I'll use my little bar there, right? Repeated decimal. And that was the feet per second. If you're traveling 50 miles an hour, you're going 73 feet a second. So again, an example of a chain of conversion factors, and in this case, 2 different kinds of units, both the top units and the bottom units, numerator and denominator units that we had to change. Those are called rates. I know you're writing that all down. I'm going to go, okay? That's as complicated as it gets, folks, okay? Converting a rate. That's as tricky as we'll try to throw at you. I'm pretty sure. All right, how about some metric units? All right. Now, some of us may not be as familiar with the metric system as others. A meter, that's that length. It's real close. It's 39 inches roughly. It's real close to a yard. A centimeter is real close, roughly to about ½ an inch. You know, just give you some reference. Nice thing about the metric system is the relationship between the units in the system are all powers of 10. A meter is that long one. 1/10 of a meter is called a decimeter, like decimal, right? Decimeter. 1/100th of a meter is a centimeter, like century, right? Centimeter. 1/100th and 1/1000th of a meter is a millimeter. 1,000 little lines in that yardstick, that meter stick. So it's kind of nice, lots of powers of 10. But we need to find the conversion factors that are going to get us where we want to go. I'm looking at that handout that I mentioned is in my open math, and we're talking about lengths. So you kind of got to look down that list to find the ones that are going to work for you. Now there's a couple different ones. As I look down this paper, I see here it tells me that 1 meter or 1 centimeter is 1/100th of a meter. That's true. Another one further down, it's kind of like going the other way around. It says 1 meter equals 100 centimeters. Now, if I multiply this by 100, I get that. And if I multiply that by 100, I get to that. So it's just which perspective are you thinking about? How big is a centimeter compared to a meter, or how many centimeters in a meter? Either one will work for us. So I just want to change this number of meters into how many centimeters. Same setup I'm going to use. Notice for miles, I did MI, trying to make it clear that M is just meters, all right? And I'm going to multiply by some conversion factor and end up in centimeters. I'm going to use the second one. Not so messy with decimals or something. So I'm going to put meters opposite, same process. And it means the centimeters are on top. So 1 meter is 100 centimeters. Ready to go. The meters cancel out. That was the point there of the setup. 2 times 100, 1 meter, or 2 meters is 200 centimeters. All right. So maybe a less familiar system to you, but find the conversion factor on your table and see if you can follow the same setup process, right? I think our metric table even tells us, oh yeah, 1 meter is 1,000 millimeters. So they're giving you all those relationships there that you can use. All right, how about grams to kilograms? All right. Kilo is the metric system term for 1,000, right? Kilometer is 1,000 meters, sort of that similarity to miles in our system, right? A gram is their sort of small mass or weight unit, is the small. Although you can get to milligrams and so on. There you can get smaller, smaller, smaller. In fact, if you're talking about dosages or something, or taking your prescriptions, it might be in milligrams. I've got one I take in micrograms, you know, some tiny amount of some stuff I have to take. Anyway, I want to change my grams to kilograms. Well, kilograms, 1,000 grams. 1 kilogram is 1,000 grams. Definition of kilo. A kilometer is 1,000 meters. Now, yeah, liters, kiloliter, I suppose they might do that too. I never hear of kiloliters, but it's always how many liters. But same process, 2,800 grams, and build my fraction out of the relationship there. Means I want grams opposite, and kilograms will be on the top. The grams cancel out. 1 kilogram, 1,000 grams. All right, so I'm dividing by 1,000. Remember your any powers of 10 processes there, you know, if I divide by 1,000, I'm just moving that decimal point over 3 places. How many thousands in 2,800? 2.8. Put that in your calculator, but anyway, it should come out 2.8. 2.8 kilograms. All right, and how are we doing? Good. Not a whole lot trickier, but I'm going to now do some English system to metric system and vice versa. So going between the two systems. Oh, okay, yeah, that's a good point. Good place. I got to use this. I'm thinking like, oh, I'm going to remember to do this one. Oh yeah, it'll come up here in a minute. 2.5 liters to quarts. Liters to quarts. A liter is very close to our quart in size. I think a quart is 0.99 or 98. Oh, it's probably right here on our sheet. 1 quart is 0.95 liters, according to this conversion. Yeah, relationship between quarts and liters. Here's where you're definitely going to want to use your calculator because you're going to get some messier numbers. I think, unfortunately, I don't think the MyOpen math questions tell you how many decimal places to round to. I think if you put into my experience is I think if you round at about 2 decimal places, you'll be safe. Okay, it should be more specific, I think, with just the program. Sorry. So liters to quarts. All right, so I have 2.5 liters, building that fraction. Conversion factor, and I want to end up in quarts. So I'm going to build that conversion there. Means I'm going to put the liters on the bottom and the quarts on the top. Liters will cancel out. 1 quart, 0.95. I'm dividing by a number less than 1. That means I'm going to end up with a number a little bigger than 2.5. Here we go. Get out of there. Clear. Where's my clear button? There it is. 2.5 divided by 0.95. And I've got 2.6315, blah, blah, blah. I'm going to just round to 2 decimal places. So 2.5 liters is approximately 2.63 quarts. Went between the systems. All right. Examples I've got here. $5,895 meters to feet. All right, what do I have to work with? Oh, there it is. Meters to feet. Oh, well, there is one right there. Different versions of a table like this might have different conversions available to you. You're welcome to use any other conversion table you find. Some of them have more decimal places in them, so your answer might be just slightly different. If you really think you run into a problem like that, let me know. But this one says 1 foot equals 0.305 meters. Remember, if a meter is about a yard, 1 foot is a third of a yard, right? So 0.3 is close to a third. Anyway, we're in just a little estimating, we're in the ballpark. So converting this number of meters to feet. And so I want meters on the bottom, feet on top. 1 foot, 0.305. And the meters will cancel and I'll end up with an answer of feet. And here we go again, right? 5895 divided by 0.305. 19327.8. Now this is 0.8688, so I'm going to say 0.87, right? Going to round to 2 decimal places correctly. And what were my units? Feet. Don't forget your units. I think my open math's pretty nice to you. It gives you the units, you know, on a written test. You'd have to remember to put the units in yourself. That's an unfortunate little error if you forget to say what kind of units you are talking about. All right, so same process. We just find the right conversion factor to use to go between the two systems. There's one problem I noticed. Oh, somebody's trying to message me or something. I think that was it's probably my email or something. Sorry about that. Oh, I noticed one problem in your homework that asks you to go from miles per hour to kilometers per hour, or maybe it was the other way around. Notice that these are both rates, but you're only asked to change the length part, miles to kilometers, or backwards. You don't have to do anything about the hours. The hours will be there throughout the whole problem. So just pointing that out, I saw that in a homework problem. We did that more complicated rate problem where we had to change the hours to seconds. This one's simpler than that. All right, that kind of worked through my examples there. Oh, let's see. There's also 1 or 2 in the homework where they ask you to convert temperatures, Fahrenheit to Celsius. And
Sorry, may I ask a question?
yes, please, go ahead.
For that right there that you're erasing, I got 1,797.97. What did I do wrong? I did it like 3 or 4 times.
Okay, did I get the right numbers? 5895. I did meters to feet. Right? Are we okay with that so far?
Yeah.
Thanks for asking. Sometimes I push the wrong button.
Maybe I didn't do it right.
And double check, make sure I used the correct conversion. So the conversion I have that I pulled off of this sheet over on the far left column, it says 1 foot is 0.305 meters.
Right.
All right, so 1 foot, 0.305, and I'm going to end up with feet. Now, I make mistakes occasionally too, duh. Hopefully not too often for your sake, right? So this is divided by this number, right? Divided by 0.305. I got my 19327 again.
I don't know what I'm doing. I must be doing something wrong. I don't know. I still keep getting.
Well, double check. Be sure you get your decimal point and the 0 in the middle. Did you get that 0 in there?
Yeah, I'll work it out later. But thank you. I just.
Okay. No, that's what you need to do. Ask the question. All right. How about Fahrenheit to Celsius? All right. And there are is a conversion factor. It's a little more complicated formula, you might say, going between the Fahrenheit and Celsius than just that simple fraction. So your problems will tell you the little equations to use. If you're going from Fahrenheit to Celsius, you want to use the version, the equation that tells you my final Celsius answer is going to be based on whatever I plug in to this little formula. All right. Going the other way around, if I was trying to go from a Celsius and end up with Fahrenheit, so you want to end up with the Fahrenheit number here, and that's the one that is kind of, if I unwrap this one up, actually really, we'll do this in the next chapter. Solve this for Fahrenheit, move everything around so Fahrenheit's all alone. Anyway, but I'm trying to go from the Fahrenheit to end up at Celsius, so I want to use this version. And the homework problem actually tells you to use this one, the correct one. So I'm going to plug my 78 right in here. So then it becomes kind of like an order of operations problem. And you get to use your calculator. It looks like I'm going to get some messy decimal answers since I just made this up. So 78 minus 32 is going to get me 46. So that's multiplying this fraction times that whole number. I might just think of that as over 1. I'm going to put that in my calculator and say 5 times the 46 and divide by the 9. I'll call it, it's 55555. I'll call it 25.6 degrees Celsius degrees. So for the couple that are, I think it's the last couple homework problems in the 110 section, ask you to convert from one temperature to the other. And they give you the right formula to use. Plug it in and then simplify. Okay. Well, I'm going to say that's it for today. Unless you have questions right now, that's fine. No problem. You want me to do another one of something? Or, But I think there's about a dozen homework problems related to this section. And see if you can set them up and work them through. The first few are just the, I want to say the simpler ones, this unit to that unit into one conversion. Eventually you get down to a couple where you might have that chain of conversions, need a couple of steps in them. All right. And tomorrow we'll look at perimeter, area, volume, geometry applications. Basically, if I've got this geometric figure, can I figure out the dimensions? What's inside? So that one's all, it's just a lot of plug the right numbers in and do the calculation. So again, it's a good class to show up for or watch the video. All right. All right, folks, I'm going to let you go for today then, and do your best and send me your questions as always. I'll do my homework. I'm grading your papers. Hopefully you'll see those grades soon.
Thank you, Steve.
Okay, you're welcome. Have a good day.
You too.